We want to prove the product rule for differentiation, which states that when you have a product of two functions, f and g, the derivative of that product is going to be the first times the derivative of the second plus the second times the derivative of the first. We start this proof by going back to the definition of a derivative, which is the limit of the difference quotient. So notice all I did was I took this product, which is a function, it's a function of f and g, a product, and I plugged it into the difference quotient. So I've got f of x plus delta x times g of x plus delta x, and then minus f of x g of x all over delta x, the limit as delta x goes to 0. So this is a straightforward plugging into the difference quotient. Now, the key to this proof is to add and subtract this term, f of x plus delta x, g of x, and here I subtracted it off. So I added it and I subtracted off the same thing. So I've really done nothing. So notice, this is the difference quotient, only I've put these terms in. The reason I did that, which that seems like foolishness, why would I add something and then subtract it off? Well, I did it for this reason. I did it so that I could do a regrouping. What I'm going to do is I'm going to take this this difference quotient, take this first term, and put it here. Then I'm going to take this that I subtracted off, f of x plus delta x g of x, and put it here. All over delta x, and I still have the limit as delta x goes to 0. Then I take the rest of the difference quotient, this part, the f of x plus delta x g of x, and I put it with the f of x g of x, and I have another limit here. So what I've done is I've taken the limit of this sum and I'm looking at it as the sum of two limits, which is valid. So I've done nothing here that's not valid. Now what I want to do with this first limit is I want to factor out this common factor of f of x plus delta x. I've got one here, and I want to factor it out and put it out front. And what that leaves me with is I've got the limit as delta x goes to 0, f of x plus delta x, times the limit of this thing, which is the difference quotient for g of x. So I've got, what I had up here was a limit, and now I've broken into a product of two limits. So these are the same. Now notice that the rest of this limit over here, I factored out the g of x and gave it its own limit. Delta x goes to 0. And then what I have left is f of x plus delta x minus f of x over delta x. So what I've done from this step to this step is just some rearranging, some factoring. Now let's look at this first pair of limits here. First of all, the limit as delta x goes to 0 for f of x plus delta x is just f of x. So I'll put it here. The limit as delta x goes to 0 for this thing is by definition the derivative of g of x. So I'll put it here. Over here, the limit as delta x goes to 0 for g of x. Well, g of x doesn't care what delta x does. It doesn't have a delta x in it. So it's just g of x. I'll put it here. Then the limit as delta x goes to 0 for this part is by definition the derivative of f of x. So I'll put it here. This is what I want it to show.